I'm Steve, and welcome to Keithley Briefly. Today we're going to be talking about NPLC, or aperture. This means the number of power line cycles, and it describes the amount of time that an input signal is integrated in order to get a single measurement. This is going to be based on your power line setting. So for 60 Hertz, 1 PLC will equal about 16.67 milliseconds, and for 50 Hertz, about 20 milliseconds. By its very nature, power line noise is periodic. And so if we were to draw it on a graph, it would look something like this. Now this amount of time for measurement, which is about 33.34 milliseconds or 2 PLC, would be a relatively quiet setting for PLC because you have equal parts positive and negative power line noise being integrated into the measurement. Now if you were to use any whole number, you get the same effect. 1, 2, 3, 4, and so on. If you were to use a fractional PLC, such as 1.5, then you see that you would get more positive noise than negative noise. If you go even lower to something like 0.5, then you're getting only positive noise. And once you get down to a quarter or an eighth, you can see that it has much more effect on each individual measurement, and you're going to get a very variable amount of power line noise per measurement. Now, one caveat to all of this is that though it tells you the amount of time it takes to integrate the measurement, it isn't the full measurement time. There are some other factors which we'll go into in later Keithley Brieflies. But the basic takeaway from all of this is that if you want very fast measurements, set your PLC as low as possible. And if you want very quiet measurements, set it as high as possible. Typically we recommend about 5 or 6 so that you still have some speed left. Alright, so that was NPLC, or aperture. If you have any further questions, please feel free to contact Tektronix Technical Support. We'd be happy to help.